audible? Yes, so we talked about unsupervised learning last time. We discussed expectation maximization algorithm. And I think most of the probabilistic approaches that we were to discuss are covered with that. And we move to other clustering techniques, other unsupervised learning techniques from today. I would say most of the difficult part of the course is over. And now the algorithms that we are going to discuss are pretty simple and have a wide range of application also. So let's begin with one such popular algorithm known as k-means clustering algorithm. Let me share the note. So a very basic and popular clustering technique that we are going to discuss today is called k-means clustering algorithm. We'll see what how it works. As I said, of expectation maximization. But before that, let me uh, give you some insight through data. Let us create some data points. Let's say if we have data like this, two features only, x1 and x2. So now the kind of learning that we are talking about is unsupervised learning, right? So we are in an unsupervised setup. So we do not have class label. We just have features x1 and x2. And by looking at this number, we want to make some sense out of it. We want to see how these numbers are related to each other. So from what we know so far, we know that these data points are vectors in some n-dimensional space. In our example, since there are two x1 and x2 data points, so we have two-dimensional space. For vector x1 and x2. Just let me do it like this. Right? And if we plot them on this n-dimensional axis, then they would look something like this. 1, 1 stays here, then 1, 2 stays here, 3, 4 goes here, then 6, 7 goes here, 8, 9, 8, 9 goes here, and 9, 9 goes here. And then the 6 data points are residing in this two-dimensional space like this. Now, we do not have class labels or we don't have any other information, but we want to make sense of this data point. So what kind of questions we can answer from this data points and from this visualization? So it can be something like this. A very common intelligent task is categorizing and grouping. So if I ask something like this, let me number the data point also. It's called P1, P2, P3, P4, P5, and P6. As we see here, this P1, or something like this. So if someone asks the question like, what are the chances, or okay, let me see if okay, what are the chances of seeing P1 and P6 together, or seeing P1 and P2 together, right? We may say that P1 is more similar to P2 than P6, right? Even if we do not attach any semantics to the problem, or we do not go into any details of where this data is coming from and what is the purpose of such data, we can make such kind of observations by looking at the plain data itself. Right? Are you with me so far? So essentially, what we are doing is we are trying to relate data points based on distance between them. Just a second. Yeah. So are you with me on this? Any question? What we are trying to relate, what we are trying to do so far is we are relating data points based on distance between them. And our basic idea is lesser the distance, more similar these data points are. Right? Like P1 and P6 are far from each other. P1 and P2 are nearer to each other. So there are chances that P1 and P2 are more similar to each other. So we are trying to group the data points based on distance between them. We want to do something like this. So we may say that these three data points are in one group and these three data points are in another group. And we name this group as cluster. So this is cluster 1, is cluster 2. So essentially what we are doing is we are creating clusters of data points based on the distance between them, based on distance between them, the distance that we can view directly from the graph. But of course, for mathematics, we need some formula for distance. So the technique that we are going to discuss, it has many applications, like finding similar objects nearer to all these applications of math-based clustering. Okay, thank you saying voice is breaking everything. Yeah, I'm also experiencing some delay when I speak and when I get the on screen. The network is weak today. So is the voice better now? Can you hear me now? It is still bad. Okay, still saying network is not good, sir. We are trying to group the data points based on distance between them. And how do you take distance? You already know some formula to distance, but let's try to revise and see this idea. So let us say this is data point 1, this is data point 2, and dimensions are is 2, 3. So this is 3, if I want to measure distance between them, which is there are two ways of doing it. Let us say this is P1, 2, 3. This is P2, 3. So one measure MB, distance of P1, P2 is equal to mode of 2 minus 3 plus mode of 3 minus 4, which is 2. Yes, so network is creating them. So there is considerable lag between what I speak and what you see on the screen. Is the audio better now, or is it still breaking? I guess audio is better now. One measure is, as you can see in the screen, is distance between 2 points as a direct distance 2 minus 3 plus 3 minus 4 is equal to 2. This is one way of doing it. And second way of doing it is called so something like this. These two distances are technically known as. Have you heard about two distance before? Have you used this somewhere in your formula? This one is called L1 norm. The first one is called L1 norm. Second one is called L norm. And similarly, there can be LA norm, which is distance of equal to A through of this is called LK norm. But I think you have seen distances before. Have you anywhere to know this formula? Can you hear me? I think. Is the audio better now? Can you hear me? No, like is saying still voices breaking. So let's type this question. what I'm asking is, have you L1 norm and L2 norm distance formula before? Priyank says yes, L2 norm, yes. And this L2 norm we popularly know as something called, what we call it, Euclidean distance. And L1 norm is known as Manhattan distance, right? Why is it called Manhattan distance? Because in Manhattan is a squared city distance from it. So it is also called taxi distance. So if you notice, L1 norm is calculated as sum of difference on x-axis plus difference on y-axis. So this green line is Manhattan distance plus 1. L distance or taxi distance is Manhattan distance that comes to be 2. So how much you need to travel on x-axis, then how much you need to travel on y-axis. If your turns are always rectangle, that is called Manhattan distance. On the other hand, Euclidean distance is distance that you get as shortest path between the 2 points. So this is Euclidean distance, and this is Manhattan distance. Right? As Euclidean distance, you get the shortest path. As Manhattan distance, you get the tangent distance. Or as Manhattan distance, you get time distance. You need to travel in every dimension. So these two are very popular now, but obviously Euclidean distance is more used because it creates the shortest distance. So let's come back with the clustering form where we want to group items based on distance. And now we have distance formula, Euclidean distance also. So let me copy paste the data points again. So what do we do here? We Want to group data points based on distance between them. And so what we do is start with start with anchor points and start k anchor points and group data points to nearest anchor point or centroid and repeat this process. Calculate new center and repeat the process until no further changes are observed in the centroid. This is what we do. Let us see how we achieve this. So these are the step 1 and 2. So let's say step 1 is start with K anchors. So let's say in our example, want to group into clusters. So K is equal to, and these points that we choose are, they are chosen at random actually, but let's say for me it is 1, 1 and 2 is, sorry, not, let us call C1 and 2. So I'm choosing the data point, the cluster points from the data only. Usually it's done that way, but it can be something else also. So my choice are 1, 1 and 8, 9. These are the two data points I have chosen. So we start with K anchor point centroid and group data point to the nearest points per centroid. So there are two centers around which we want to cluster our data points. So let's calculate distance of every data point from this centroid. Let me add 2 more rows. Yeah. One distance from C1 and second is distance from C2. and one point assign cluster. And for distance, to calculate distance, we use Euclidean distance or form. So what is distance of C1, C1? C1 is 1, 1, C1 is 1, 1. So it is square root of 1 minus 1 square plus 2 minus 2 square is equal to 0. And distance of C1, C2 is 1 minus 8 square plus 2 minus, sorry, plus 1 minus 9. It's 1 minus 1, 1 minus. One minus 8 square plus 1 minus 9 square. That is 49 plus 54. What is that? 113. So which one is less? This one is. So we have calculated this distance 0. We calculated this distance square root of 113. That's why the cluster assigned to this data point is C1, because the distance is less from the C1. Are you with me so far? The audio is not reaching properly, but could you get for calculation the. So can you complete this calculation? I will do it for one more point and ask to complete, because the audio is not going well, so we need to rely on input. So now let's calculate P2 C1 and P2 C2. That is again 1 minus 1 square plus 2 minus 1 square is equal to minus 1. You see, as per this two value, again P2 will also be assigned cluster 1. Now can you complete this data point? I will wait for 5 minutes and see your answer. Do this clear calculation and decide the cluster for every data point. So let me know the value once you have finished the computation. And I guess P4, P5, and P6 will go into C2. So this distance will be C. P5 is second cluster, so this distance will be 0. Then some root values to you. Yes. Right. Are you all with me so far? So we have two clusters where 1, 2, P1, P2, P3 are in C1 and P4, P5, P6 are in C2. Now the task is we had started with randomly selected cluster heads or anchor points or centroids, where we selected C1 and C2 to be 1, 1 and 8, 9. Now, once we have a new cluster assigned, we can recompute this cluster head as follows. Like C1 has 3 data points, C1, C2, and C3, and their values are 1, 1, 1, 2, 3, 4. And similarly, there is second cluster C2, which contains P4, P5, and P6, and their values are 6, 7, 8, 9, 9, 8. So what do we do after this is calculate the new cluster head for these clusters using these data points. So x-axis for this P1 is P1x is equal to 1 plus 1 plus 3 divided by 3. And C1y is equal to 1 plus 2 plus 4 divided by 3. This is 5 by 3 and 7 by 3. Right? And similarly, for cluster 2, x coordinate is 6 plus 8 plus 9 divided by 3 is equal to 8. No, not 8. 23 by 3, almost 8. And C2y is equal to 7 plus 9 plus 8 by 3, that is 8. Right? So if we go back to the graph which we started with, so we have two clusters, C1 and C2, and cluster centers now are, in the second case it is almost 8 and 8, so somewhere here. Cluster center is somewhere here. The new centroid is 23 by 3, 8. Actually, somewhere, not here, but somewhere here. Right, 8, 8. And another one is 5 by 3, 7 by 3. Both are near 2. Less than 2, less than 2, somewhere here. Right, so these are the new cluster heads now. And what we do is we repeat this process. Now we do it for the next cluster head. So after this, to calculate distance of every data point from the new cluster head and repeat the procedure. So if you again recalculate the data points, you would know that in this case, in this example, in second iteration also, there would not be any change in the cluster assignment. So when there is no change in the data point cluster, cluster, assignment of data points, cluster 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 assignment When there is no change in the cluster assignments of data points, stop the algorithm. Algorithm stops when there is no change in the cluster assignment. Right, so this is k-means clustering in a nutshell, where we start with the initial random assignment of the data points and then keep on updating the assignment. With every cycle, we update the center of the cluster, recalculate the distance of data points from the cluster, and keep on repeating this until there is no further change in the data points. So some characteristics of k-means clustering are k-means clustering is a distance-based clustering technique. Then total number of clusters is fixed. There is a fixed number of clusters. So before you run the algorithm, you know that in how many clusters you want to divide the data points into. In our example, we did with two clusters. So you have to decide it in advance. So algorithm starts with randomly selecting k cluster heads, where we want to divide it into k clusters. And then calculate distance of data points from the cluster heads and assign data points to the nearest cluster. After every iteration, recalculate cluster head based on the mean value of current data points in the cluster. And Repeat the procedure until there is no change in cluster assigned to any data points. Right? This is how it works. Essentially, it's a pretty simple algorithm. And since audio is, I guess, still not coming properly, I have noted down all the points. So have a look at this. Sweta says, what if two data points have same distance from two cluster heads? Means, yes, then we randomly assign it to any one of the clusters. But we need to be consistent in our policy, right? Assign to the any one of that. So it can be random assignment also. And that randomness is, there has to be consistency in the randomness in the sense that you can look at the sequence of cluster points, and whichever cluster point is earlier in the sequence, assign to that. Because otherwise, if you make it completely random and if it keeps on switching between the two cluster heads, then your algorithm would never terminate. Right? So this is how it works. We'll see this in lab this time, this Saturday. I'll wait for a minute if you have any questions, or we'll end today's lecture. Okay, so if there are no other questions, we will end here. Thanks.